We looked at the process of building the Petronas Twin Towers over a period of weeks. Therefore, this presentation is about environment and safety as important as construction. Number 0 is the outline. Physically, rising buildings is important, but consideration of the environment and safety is essential to become a highly usable skyscraper. This week, we are going to talk about core and elevator planning, disaster prevention, heating, ventilation, and air conditioning in line with the theme of environment and safety. In particular, it will explain how engineers considered building in accordance with the environment and safety in terms of construction plans. The first is core and elevator plan. The core is not only responsible of structure in the building, but also focus on vertical transportation facilities and various equipment elements. This is a key factor in determining the usability of a skyscraper plan. Like the core type used the cleanest single-zone core and the most structurally stable central core in the line seemed to cover a weight of 32,500 tons and a height of 452 meters. The ratio of core area is determined by area of core compared to area of exclusive use. Various systems were used to reduce the core area ratio because various facilities were added to the core as they were upgraded, and as the core ratio increased, the dedicated area decreased. The Petronas Twin Towers are 92 stories tall and require an average of 11,000 people to move between floors each day. Therefore, various systems were considered to serve the core area ratio. In the case of high-rise buildings, the vertical transportation system is usually based on a multi-zone system classified into several exits, such as low, middle, and high altitude zones. The Petronas Twin Tower has a large vertical passenger transport system divided into lower and upper floors with sky lobbies on the 41st and 42nd floors. There are each 12 double-decker lifts and 5 double-decker shuttle lifts in the sky lobby. In the case of skyscrapers, the size of the service core becomes too large. A sky lobby system can be adapted as a solution to maintain a service core at an appropriate size and level of response time. There are 3 types of elevator zoning: conventional, sky lobby with single-deck shuttle lift, and sky lobby with double-deck shuttle lift. In the case of Petronas Twin Tower, the third type of sky lobby with double-deck shuttle lift is used to reach the sky lobby and consists of a system that transports elevators from the sky lobby to each region. This system allows users to move quickly to their destinations without being crowded. In addition to optimizing core area ratio, the Petronas Twin Towers planned a total of 38 elevators in each tower, 29 double-deck, 4 single-deck, 2 emergency, and 3 service elevators for maximized user usability. The second is heating, ventilation, and air conditioning system. Kuala Lumpur, located at the western end of Malaysia, is only 3 degrees from the equator. Therefore, a hot and humid climate is formed with an annual average temperature of 30 degrees Celsius and an average humidity of 65%. Petronas Twin Towers are exposed to sunlight during the day, with approximately 50% of the exterior of the building in this environment. That's why Petronas Twin Towers focus more on air conditioning than heating. To take a closer look at the facilities used in the building, the load includes human, lighting, equipment, and external thermal load, which consume 589,600 million BTU per year. The chilled water system was used to address this load. The system sends cooling water inside the building to absorb the building's heat. The Petronas Twin Towers used this system to reduce the annual load by 50%. However, the system used for the comfort of occupants cost $850 million a year. Like ordinary buildings, skyscrapers are difficult to ventilate through windows because the strength of the window rises significantly as they go up. In addition, natural ventilation through windows at Petronas Twin Tower, which were the tallest in the world at the time, would always have wind of the rate 6 meters per sec. Since natural ventilation is not possible, the air handling unit system is applied. The most important thing in air handling unit system is to minimize the occupied area. This is why Petronas Twin Towers installed separate air handling unit system on each floor. Third is disaster prevention. Disaster prevention measures may be divided into natural and human disaster. Typical natural disasters include typhoons, earthquakes, and lightning strikes, and human disasters include force, explosion, and fires. These disasters play an important role in skyscrapers. In particular, in the case of disaster prevention plans for skyscrapers, the minimum requirement must be met through legal regulation because the minimum legal conditions must be met. In addition, various methods have been considered for preemptive prevention. Tall and large buildings like the Petronas Twin Towers are recognized by citizens as another city inside the city. Therefore, fire safety, which is at high risk of occurrence, should be given priority. As a result, Petronas Twin Tower has a central fire prevention center on the first floor and a backup fire control center on the 60th floor to facilitate fire handling and control. Fire shutters, fire doors, and sprinklers were also activated shortly after the fire broke out. The elevator zoning is configured to facilitate the escape of users of the tower in the event of a fire. First, the lower floor can be evacuated to the first floor immediately through the core. The mid-rise can be evacuated to the next tower via the sky lobby located on the 41st floor using a double-deck elevator. Finally, the high-rise area can also be evacuated to the next tower via the sky lobby using a double-deck elevator, and sky bridge and sky lobby are planned as evacuation zones supporting separate heating, ventilation, and air conditioning systems. If a building is on fire, smoke is more dangerous than heat from the fire. Smoke generated by the fire irritates resident eyes and reduces visibility. Therefore, it may be impossible to find the escape route and emergency exit unless the occupants are familiar with their surroundings. At this time, smoke control systems help secure escape by minimizing the spread of smoke in buildings. In the event of a fire, the smoke control system sounds an alarm on the relevant floor and maintains a constant air pressure in the emergency passageways of the upper and lower floors and certain areas. This ensures that the air pressure on the floor where the fire broke out is relatively lower than that of the other floor space and the elevator passage on that floor, thereby inducing smoke to be blocked and discharged from the floor. In addition, the air on all floors except for the floor where the fire alarm occurred in adjust the support the daily activities of occupants on other floors not affected by the fire. This video is part of direct lightning strike at the Petronas Twin Towers. This table shows the number of lightning strikes per year for each country. Of this, Malaysia has 182 300 days of lightning a year, the third most frequent in the world. Among them, Kuala Lumpur, where Petronas Twin Tower are located, is one of the tallest areas in Malaysia with 280 days of lightning per year. Petronas Twin Towers can be seen shining silver in appearance. This is because the entire building is made of aluminum alloy plating with high conductivity. The Petronas Twin Towers also serve as the city's lightning load for lightning strikes in Kuala Lumpur. Therefore, lightning prevention is also a very important factor in building design. Finally, it is a reference.